Hello ELM260 industrial robotics students. I'm going to give you a quick tutorial showing you how to open a work cell in Roboguide and just some basic techniques of moving around the work cell. So if you're on the Blackboard page for the course, you click on course content, and I'm going to jump into the first module that has a lab in it. Module 2 has the first Roboguide lab. So if you go down here, you see Roboguide Cert Labs 1, 2, and 5. So this tutorial assumes you've already got Roboguide installed. There's another set of instructions for that. If you do, you want to open this work cell that's called LR200 ID V830. Click that, and it should download. So it's a zip folder. If you click it and open it, you're going to see a folder inside. So just drag that out onto the desktop or someplace on your computer where you know where it is. You must put it on the hard drive of the computer because it won't work if you drag it onto a USB, for example. It won't open. Okay, and so that folder, you want to open that up. And inside the folder, you'll see a bunch of subfolders, and this is the icon that you click. Double click it, the one that's called LR200 ID V830. Double click that, and that will open the work cell. So it'll take a little moment to open. Just be patient, and it will come up. Okay, and you'll see a window that comes up. You can just cancel that, and I like to close this window. We're not going to need that right now. So here's your work cell. Now you also need to bring up the Teach Pendant, which if you click this, it will bring up the Teach Pendant. Now let me show you something. If the Teach Pendant comes up looking like this, you want to click this IP button. This brings it up to look more like the actual Teach Pendant on the robot. The other one is an older version. Also, there's this other button where you can either have the Teach Pendant inside the window with the robot. If I click that, or you can click it to make it an independent window. I like it to be an independent window, but that's up to you. Now, there's some very important mouse commands that you're going to be finding very useful to move the work cell around and change the views. So yours may come up by default, but mine I have automatically hidden. If you lose them, you go to the View menu, go to Mouse Commands, and this gives you a list of useful mouse commands. So the ones that I use most often, if you have a regular mouse, you do a right drag to rotate the view. And you can rotate it to look at the top, the side, any view like that. So right drag will rotate. Now if you want to just pan the view, you have to hold Control key and do a right drag. So that moves the view back and forth. Then to zoom in and out, use the roller if you have a roller on your mouse, or if not, click both left and right and drag, and the view will move in and out. And it will zoom according to wherever you are centered in the view. So those three, between being able to rotate the robot, pan the robot, and zoom in and out, those three will probably get you any kind of shifting of the view that you might need. There are some other mouse commands that you can check out here if you want, but I find with those three you're pretty much all set. I'm going to close that for now, and let's look at just basically moving the robot. So the first thing you have to do is turn the Teach Pendant on, and it should come up by default showing that it's in joint mode. You see this, it says joint up here, and the buttons, the jog buttons, should all be labeled J1 through J6. There's also J7 and J8, but those don't apply because we don't have axes 7 and 8. So in the lab, what you're going to do is just try them out. Just see what happens when you click each of those jog buttons. See what joint 1 does. Okay. See what joint 2 does. All right. So just try each one of the joint 3, positive and negative. Joint 4. Okay, so that's what you're going to do, is try those joints out. Whoops, I kept that going. Now in the actual robot system, you have to hold the shift key while you're pressing the jog key. But since you only have one mouse, it automatically presses the shift when you press a jog key. Okay, the other coordinate system we're going to look at moving in is world. So joint was just moving joints individually. Now if you go down here to the coord button and keep clicking it until it says world, now you notice that the buttons now say X, Y, Z, and then rotation about X, Y, and Z. So you're going to try these as well and watch what happens, how the robot moves. Very different type of movement, and I'm not going to go over that here. That's something we're talking about in the lecture, but you're going to try each one of the movements. Now the interesting one is the rotational movements. When you rotate around X, it's as if the axis that you're rotating around is a pin, and it's fixed, and then the robot hand is rotating around it. And if you notice, the tool center point, that dot at the end of the tool, doesn't move when you rotate about the axes. So that's why we call X, Y, and Z the positional axes, because it sets the position of the tool center point, and then the yaw, pitch, and roll, the rotation around X, Y, and Z, are the rotational or orientation axes, which sets the orientation of the robot around X, Y, and Z. Now, the one more thing you're going to do in the lab is to check the position of the robot. So let me move it out a little bit so it has a little bit of a different position, maybe over here like this. Now, to check the position of the robot, you click the position key, POSN, and what you'll notice is it comes up showing initially the joint angles of all the joints, joint 1, 2, 3, 4, 5, and 6. Those are angular values. If you want to see the X, Y, Z coordinate values, you click the world button, and then it comes up X, Y, Z, yaw, pitch, and roll. Those are the X, Y, Z values are the distance in millimeters from the world origin, which is right inside the body of the robot. So we're 344 millimeters out from that point, we are 122 millimeters off to the side, and we are 43 millimeters up. And then these three, the W, P, and R, are the rotational values, the rotation around X, Y, and Z. Okay, so that's pretty much all you need to work with for the first lab. Good luck, and we'll see you online.